Hello community! So great that you are back. Today we're looking into the future. Let's have a look at the next step of the Agentic Web. Now, this will be a complete new technological paradigm that we are faced with, because the current state of the art in AI is defined by a fundamental architectural mismatch with the next generation of AI. Why? Because currently we work with LLMs and single agents. So LLMs with an emergent capabilities for complex multi-step reasoning, yet they operate here within an internet architecture predicated on a stateless, human-driven regressed response model. Great. This was okay as long as humans use the internet. But how do we architect now a new computational paradigm that enables multiple agents to transition now from a reactive response role to a proactive, goal-oriented problem solver in a persistent, stateful, and collaborative manner? Look at this. Future will be if we have an agent, a user has here a request, and the agent says, hey, the user asked me to do the following. So, agent will go and said, okay, I make now a plan. The planning here of our reasoning model is great. Then do a search, an internet search. Maybe it is stuck, so it says, hey, I have to recruit special agents, I have to build special agents, or I have to buy specialized agents from global corporations like Microsoft, OpenAI, or Google. Then, plan continues, we come to the action phase. Here we have the tool interaction, here more collaboration with agents, here new data streams, SQL, whatever we have, internet searches, and we can have inter-agent discussion rounds here to find the best solution. And finally, we come back here and the agent has now a solution and presents this to the human user. And you see the human, me, I just had a question and now I get the answer. And I don't have to touch anything at all. So today's video I will incorporate 3 brand new publications that were published today. And more of the 200 papers that I tried to scan through today, those 3 were really interesting because they go together. First paper will represent the vision of the new web. 77 pages here of detailed instruction. What is the next internet generation? Then we will have a look at the implementation of this new idea, of this vision, a blueprint here in action. And you are familiar with 90% of this. And plus we will have then the validation phase. We have to evaluate here the performance of multi-agent systems. And those are the 3 studies we're going to look at. First study is by Shanghai University, Hong Kong University, University of Liverpool, University of California, Berkeley, Shanghai Innovative Institute, University of California, Davis, Virginia Tech and University College London. Second is from Stanford University and George Mason University. And the third one is from SAP Labs. Great. So we have now a systemic evolution that goes now from multi-agent system to a semantic web structure based at a next layer on the internet protocol. On the internet itself, to be specific. So let's have a look. What is the vision? The prophecy here of a new web emerging here with multiple AI agents. They define here that we are entering a new era, the Agentic Web era, no? A distributed internet ecosystem where autonomous software agents, powered by intelligent LLMs or vision language model, act as the intermediaries to persistently plan, coordinate, and execute goal-directed tasks on behalf of human users. Great. And they say, we had the PC web, where human browse the web of static documents here. Then we had the mobile web phase, where human interact with a web of curated apps. I don't know, I have 20 apps on my phone. And the next one will be an agentic web. Human delegates every intent here to a web of autonomous agents. In this phase, a human doesn't need any apps anymore, because the primary interaction becomes a machine-to-machine, a dynamic and orchestrated collaboration to fulfill here the user's goal on a complete different complexity level than a human can participate on. So here's what here the first paper shows us here, the PC web era, then the mobile web era, and now starting 2025, the agentic web era, AI interfaces, multiple AI agent, intelligent runtime, cloud infrastructure, key characteristics defined. Great. So therefore, let's assume for a moment we work with a scenario where classical apps that you have all the time around you on your iPod, on your iPhone, or whatever you use, an Android phone, they might cease to exist. Because why should a human use an app? Why should a human develop an app any further in 2026 when we have multi-agent system? So let's go and say, listen, this AI hype is real. If in the US they invested more than $100 billion just in the development of the next generation here, there is a momentum building that AI will continue in 2026. And they have to come up with something else, and they have to bring a rate of return and a rate of investment. And now we need to see some new market dynamics. But let's say that the humans would only use apps, no? And if I have agents on my phone, I don't have to touch my phone anymore. I don't have to open apps, anything, because agents have a different intelligence workflow. We program it today, and we see we don't need apps anymore for human interaction, no? So there we have it. And the authors tell us we have identified 3 dimensions to this. The first is the intelligence dimension. No? This is the agent's brain. It's not anymore about retrieving information, not about RAG, graph, or anything. No? It is now about multi-step reasoning, the causal reasoning, the understanding of the context, the prediction of future possibilities, long horizon planning, adaptive continuous learning, contextual understanding. Agent must be able to reason about their goals, not just react to prompts or build some app. And then we have the complete new interaction dimension. No? If you want, this is the nervous system of this new ecosystem. No? How do agents communicate? The old web's HTTP request response is absolutely insufficient. No? So this calls for new agent native protocols here, a new layer on top of the internet that allows here only the agent to discover each other, negotiate, orchestrate complex workflow. This is a pure AI layer on the internet, not for humans anymore. Then, of course, because somebody has to pay for this, and this is us, the consumers, we have the economic dimension of this new technology paradigm, because now we bring it into the market dimension. Yeah? This is now becoming a marketplace. As agents, not humans, become here the primary consumers of services. Because the classical Google-based advertising-based model, like Facebook or WhatsApp, this advertising-based model breaks down. It's not anymore working. So we need a new, if you want, agent attention economy, not the self-attention, but just the agent attention economy. And there are currently a lot of new ideas how we can build this, how we can move from advertising. Human have to click on something here. What if agent do all the work? Agent are not interested in ads. So we have to come, or a global corporation have to come up here with new business models. This creates a need for new monetization models, like micropayments for specific API calls orchestrated by your agents that you hire or that you rent out for a particular time. And you might say, hey, that sounds nice, great, 77 pages here, full of details here from multiple university, great. But how do we actually build it? How close are we? Oh, we are damn close in the implementation phase. We already have the blueprint and we already have it in action. And you know, there are just 2 foundational protocols I pick up now from the second publication, and you know both because I have multiple videos on this. The Model Context Protocol. I'm sure you're familiar, maybe you're already building with it. Anthropic MCP standardizes how the agent interact with tools and all external resources, SQL, database, APIs, files, everything. Plug and play standard for the tools. And of course, agent-to-agent communication protocol by Google, A2A. You know everything with Agent Card. I have 3 videos on this agent-to-agent protocol by Google. Yeah, classical multi-agent center, you know this. If you have a system architecture, you find in the paper specific case study, rather simple case study, all the familiar terms. If you're into this topic, you immediately understand what we're talking about. But let me give you a simple example if you're a freshman. So in the future, currently, already operational, a user has a complex multimodal query. analyze this image of a bridge and query our database for its maintenance history. Now what happens? Now in a normal old-fashioned classical system, multi-agent, you have an orchestration agent that receives the query. This is the boss of the agent. Yeah? Using the A2A protocol, now this agent discovers and coordinates now with specialized domain agent. Now given the intelligence and the pre-training and the causal reasoning and the contextual understanding of this single orchestration agent, this agent decides now it needs, let's say, 3 additional specialist agents. Yeah? It needs, for example, an image agent, or it needs here a database query or SQL agent, or it needs here for historical data here a search agent here in the, I don't know, department of bridge building or whatever it is called. You get the idea. So we have highly specialized domain agents, and they use now the MCP protocol to interact with their respective tools. Vision API, SQL database, whatever. You are familiar with those terms. Everything reported back, and the central intelligence of the orchestrator synthesizes then everything together, and we know it's not working because the poor orchestrator simply overwhelmed. We have hallucination that is just amazing. So what about the validation phase now? This is now the third step. We want to make sure, hey, what we built, is it working at all? Where are we? 30% success, 50% success, 70%? The science of measuring agency. But careful, it's not about a single LLM. It is not about a single agent. We are now on a highly dense, complex internetwork of multi-agent system. So what you want to measure now exactly? Yes, of course, the final outcome. This is the simplest, no? But think about this. An LLM or a single agent evaluation is like testing a car engine here on a bench. But if you go here in agent, in interaction with the environment, with memory, with tool use, it's like testing the entire car now on a racetrack or in a city traffic. Or if you go off-roading, you assess the performance of the complete system, the reliability of the complete system, and the safety of the complete system in dynamic, changing, interactive environments. And your action space as a multi-agent system define what you're going to do next, and you will have a particular response from the environment. So these evaluation routines are completely different to everything that we know. And at least we will have 2 dimensions, what to evaluate and how to evaluate it. Now, what to evaluate seems easy, no? The agent behavior, the agent capabilities, the reliability and the safety and the alignment, yeah? Yeah, for a single construct it would be easy, but we have a multi-dimensional, multi-component, multi-interwoven communication. Plus, we have different action spaces here for our transformers in the LLMs of the brain of the agent. So, just think about the behavior. Did the agent complete the task? Well, that's easy. What was the quality of the output? Not so easy anymore. The process. Was this the right process? Was it energy efficient? Was it money specific? How well did the agent use here different tools? How well did the agent had a different tool selection accuracy? Was it working with 2 tools that were only appropriate 50% instead of choosing here 1 tool with a 100% performance for this particular task? How good was the planning for tool use? How good was the reasoning in analyzing the given problem? What is the progress rate, the plan quality? Reliability. Don't mix up reliability with safety. Reliability here is consistency and robustness. If it works one time you want in a production, hold it works now X times. Does it succeed every time? Really? How does it handle errors or unexpected changes in the environment? What about if we suddenly lose an API key? Safety, alignment, trustworthiness. Monolithic terms we are standing like little children in front of, and we have no idea how to really cut through this with a multi-agent system. Dimension 2, how to evaluate. Now, clear, we would all agree in interaction mode. No? We evaluate the data, the complexity benchmark, the specific capabilities. We have some benchmark already from software engineering task. But my goodness, this is so different to software engineering. Just think about the different metrics we could choose here for the computation. And you know what is the gold standard? They tell us here in the second paper, the human in the loop. And now a new and a compelling storyline emerges, no? We're not just building singular AI models. We are building now elements that are architected to be an integral part of a much more complex agentic dynamic web system. An agentic web, a new digital world, inhabited not by humans interacting with apps, but a world inhabited by autonomous agents performing a complete different level of complexity in interaction and reasoning. So this agentic web, if you want, operationalizes now the concept of multi-LLM powered agents by architecting a new decentralized computational layer over the internet. We talked about all the protocol problems and the economic models that we need, everything from an agent attention economy and so on. Can we go a step further? Yes, of course. So we have now a transition from a system where the humans are in the loop and the human code new apps to a system where the humans are on top of the loop, delegating their intent, their high-level intent, to multi-agent system. Since last 2 weeks, I don't code apps anymore. We have AI to code small apps or little or tiny apps like Google calls it, but AI is now coding apps. Why should a human waste time and brain power to code apps if AI is doing it? We have to tackle now the next generation of problems that come up. How we can build architectures for this. And I told you we have 3 dimensions, the intelligent dimension, the interaction dimension, and the economic dimension, where you have billions and maybe trillions of dollars that you expect the new economy. Not as simple. Let's go a little bit deeper. You understand that what we are operating here is the LLM, the core of the agent, is, if you want, only a policy function pi, no? Where we have A, our action, and H is the history of the states and the actions, and now we predict here a new action. And the objective shifts now from maximizing a next token prediction likelihood, like from a typical singular LLM, like GPT-5 or whatever you have, to finding now an optimal trajectory for the complete system that now maximizes the expected discounted return for a given goal, G, for the complete system. And just seeing this sentence makes my brain explode, given the complexity that is on the next deeper level, how we want to do this, how you want to build those reward systems for multi-agent system if they have an interconnect. So we have to go beyond what we know about standard LLMs, no? And the first, just think about planning. You remember that the agent here, that what is the goal or what is the success path? It takes a really complex human task that I give to my LLM, and it decomposes here the goal into a sequence of sub-goals and actions that have a lower complexity. But therefore, it has to have a contextual understanding. But you remember, this is only partially observable. So the agent must now have, from its pre-training, maintain or develop an internal belief state over the true state of the environment, interacting with the environment. And you know, I told you already, I don't know, in a dozen of videos, we are talking about partially observable Markov decision processes. And this is the theoretical motivation here for structured memory systems that go beyond the finite context windows. But think about the action space. We now operate in a much more complex action space, no? Because it does not include the text generation, but now includes all the action we could use with external tools that are available for us on the internet. So the grounding of language and executable action here is or was the cornerstone of agency, but not any longer. Let's talk about the interaction dimension. We talked about here that the agentic web requires here a new protocol stack that enables, if you want, a semantic interoperability and a dynamic composition, especially where you have multi-agent system probably, at an internet scale. Just think about what agent is allowed to discover here, what tool, function, signature, or parameter schema, or prediction here on what sources on the internet. Think about agent-to-agent interactions. Think about the problems we have if we only work here with agent cards. Think about the semantic misinterpretation that could happen with structured dialogue for task delegation, negotiation, and collaborative problem solving between the agents. Yeah, let's not talk about this. So what we do now is, in the next step of AI, if it comes, we have agent-driven API calls that now replace the human-driven page views. So the complete ad revenue stream system breaks down. So we must. So the global corporation will present to us new economic models for our agents. This will be an absolutely fascinating time. Scalable planning. How do we scale LLM-based planning to handle here the combinatorial complexity of the real-world long horizon task in the interaction with the external environment under uncertainty? What about protocol evolution? What are the limits here on the trade-off of MCP and A2A? How can we incorporate mechanisms for trust, reputation, or verification that goes beyond a single, the classical verification or the API keys in the stack? Main problem, what everybody's talking about, continual learning. How can agents continually adapt their policies and their internal world models from their interactive experience without the catastrophic forgetting is happening if we have CPT or SFT? I will have a new mini-series coming up on this particular topic. Plus, the science of evaluation will finally come up again on a higher level of complexity. How do we create benchmarks that are not only challenging and comprehensive, but also complex on a complete different level of systems? Now, if you are kind of interested, those are the 3 papers I selected here, published today. Agentic Web, weaving here the next web. Great. Second, Agent Master. Don't ask me why this has the date of the 8th of July. It was published today. And July 29, 2025 here, SAP. Now, this evaluation is absolutely fascinating if we go here in multi-system configurations. And SAP did a really nice paper here on the evaluation objectives, and they separated this from the process itself. And you have here what is, maybe I'll show you, agent behavior, the agent capabilities, again, reliability, safety alignment. So many open questions. We have no idea how to respond to this. We have no idea how to design the test for multi-agent collaboration system that test out here not only the single agent performance or the 2 and 3 agent group performance, the cluster performance, not a complete system performance. Is this really the best configuration? How you want to build a benchmark for this if we're working in a probabilistic environment and not in a deterministic environment? Multi-agent collaboration in itself is the Pandora box beautiful, Just think about a financial decision-making and structured data analysis. Now we do have autonomous agents that must exchange information, negotiate with each other, synchronize the decision-making process efficiently, and come to a conclusion without any human interference. And this is maybe your money. Collaborative task, collaborative efficiency, how well multiple agents share responsibilities. Think about the latest ideas that OpenAI has to give AI here legal status, legal responsibilities. My goodness, how you evaluate distributed task performance on a dynamical level for probabilistic systems. Unbelievable times ahead. I told you, reliability, safety, beautiful. And now I can tell you, if you think, hey, this sounds fascinating, yes, absolutely. But may I just notice that this was the sunshine version. And now we come to the reality. So all the papers here, and let's say the paper number 1 identifies here the need from the protocols, but we do have a protocol kind of war. We have here a bubble of agents that defeats here the purpose of seamless interoperability. Everybody wants to build its own system, its own framework. And guess what? And a lot of times they are not interoperable. The agents have to correctly interpret the semantic of the agent card in A2A and the tool schemas. This is, according to the authors, really a problem, né? Because natural language description of functions are notoriously ambitious. And even with structured schemas, concepts like book a convenient flight are underspecified and context dependent. This will lead to new and a really interesting class of new bugs that are rooted in the semantic misalignment between a multi-agent configuration, requiring now a much more sophisticated semantic debugging tool that does not even exist yet. Decentralized trust? Really? I mean, yeah, this is the most significant conceptual gap we have right now. How does an agent establish trust with an unknown entity on the open internet before delegating a task involving sensitive, your personal financial data, your medical data, or your financial transaction? It requires a new stack of decentralized identity, verifiable credentials, and maybe we really have to go here to cryptographically secure foundation models. I don't know yet. So a massive independent research field, and without it, the transactional agentic web is a non-starter for high-stake application. This is just a play field here, a sandbox for some app developer, but not a marketplace. The orchestrator, I already told you, we have here the central intelligence of all the agentic network. No? This architecture places here an immense cognitive and operational burden on a single centralized agent. This agent was responsible for all the query decomposition, for all the routing, and for all the synthesis. And the model assumes that it is easy to just decompose everything. No, in reality, the complex query, the decomposition itself can be NP-hard. The orchestrator can maintain, this is the hope, a perfect real-time model here of all the capabilities and all the current state of the load availability of subordinate agents in real time. And yeah, it's a centralized model, it's a cognitive bottleneck, and it's the single most important point of failure that will not scale. Interesting models will come up. We have a crippling latency in the call chain. Think about all the operators or whatever you see already here, or whatever you call this, an LLM takes over your computer, and you give it a more complex task, and you wait 5 minutes, you wait 10 minutes. Yes, of course, you have latency. This described end-to-end workflow represents a long sequential chain of network requests and model interferences. User, server, orchestrator, A2A, domain agent, LLM, MCP, tool API, and so on. And this is just the beginning. We are not even talking about any validation step here. So currently, the cumulative latency is absolutely unacceptable for any interactive application, the authors tell us. And we need something new. We need techniques like speculative execution. Oh, great. We already have, if you want here, probabilistic execution. And now we have speculative execution. Oh, I'm looking forward to this. Of course, we have to increase the parallelization of all tasks, subtasks, and every dependencies. And we have to have a much better sophisticated caching that would be essential, but is currently not addressed at all. The nightmare of state management in a distributed system is something, oh yeah, I leave this over to the expert. It is great. Yeah? If you work on distributed system, you know what I mean, of synchronization without a centralized transaction coordinator. We have a cascading error propagation. Think about this, what we just built, no? The framework's robustness to failure is absolutely unproven. A single failure in a leaf node, no? Like an agent API key is expiring suddenly on a particular date, could cause a cascade of exceptions that propagate up to the orchestrator. Production-grade system would require sophisticated error handling logic at every single layer, including context-aware retries, fallback agents. We have no idea how to build them here in a way that, yeah, you get it. Security. Let's talk about security. The implementation security models appear to be currently limited to separate API key for different agent create or maybe an authentication. This is absolutely insufficient. If we have a multi-agent system here that operates here autonomous on the internet, you know what can happen. Data poisoning, prompt injection attacks between the communication of the agent, no? So therefore, a zero trust architecture where every inter-agent communication is authenticated, validated, sanitized, is really non-negotiable for a secure agentic web. And then the most critical scientific gap, this is a free fall down here. Systems, systemic risk, and emergent risks. The entire evaluation framework is geared toward assessing single agent or small group performance on well-defined tasks. Imagine you go out in the real world and you have real world interaction here with a multiple group of real agents. The most catastrophic risks of a global agentic web will be emergent systemic phenomena arising from the interaction of hundreds or thousands or even more of those AI agents. We have no idea what could happen. We have no methodology to test for. Algorithmic flash crashes. Think about if we have autonomous financial agent. They could create a self-reinforcing feedback loop that absolutely could destabilize the market segment. Coordinated disinformation at scale. We could have emergent coordination between really malicious agents to generate and propagate believable misinformation. Systemic goal degradation, where agents optimized for local proxy metric for your single goal collectively produce a globally undesirable or unsafe outcome. So one department in your company might have success, but at the cost of all the other departments of your company. And therefore, in the total, the performance of your company in total will decrease. So there are problems. It's fascinating. So I say, welcome to reality. I love to read here these three beautiful theoretical AI research report from all the beautiful information on SAP in the world. But just think about with what we are dealing. We are talking here about a partially observable Markov decision process where we have a policy executor. And this is here, if you want, the object that we are optimizing in a way that we take here a human goal, a high-level goal that hopefully defines here a very specific reward function given here the analysis by this LLM. And the agent task is now to execute a very particular policy pi that selects now from a much more grown action space specific actions that are based on the text, based on the tool use, based on the communication to other agents, and based on the internal world model, understanding and predicting the outcome of its future actions, based on its current belief state of the historic action already undertook, so have a coherent sequence in order to say, yeah, this is a mathematical optimization procedure, and my job is now to maximize the expected future reward function, where this reward function can be explicit and implicit and can be mathematically modeled here with different complexity models. And maybe you get the feeling that I wanted to give you in this video about the future of AI. It's gonna be amazing, but it's gonna be a lot of work ahead of us. Yeah, all about the belief state, all about the action space, all about other states and the policy. And this little instrument of a policy optimization should be the super intelligence for the human race. Are you sure about this? Okay, what are really the next step? The next step of research must now address here non-functional requirements that are ultra low latency in the complete system configuration, distributed state consistency and coherence. We have to do something that it's on the security level that maybe we have to go to cryptographic security, and we have to find a much better, much more robust error recovery at scaling those multi-agent system. Otherwise, it's a non-starter. I hope you enjoyed this kind of videos, and if you want to see more, hey, why not subscribe, and I'll see you in my next one.